Hey guys, it's your teacher Yan. Basic integration part 3 today. And I'm going to talk about those sneaky situation in basic integration. Okay, so let's get started. First example I'm going to give you is the integral of 1 divided by 1 minus e to the negative x dx. So I know you all love the e's, so that's why it's there. Nah, really. This is a very sneaky situation here. And in your handout, this one is labeled as sneaky U, and you know, it's a sneaky U substitution. What does that mean? If you look at it right here, we have e to the negative x down on the denominator. It seems like it's calling for a U substitution, but we know that the derivative of e to some power, e to the x, is e to the x. So if you let u be this right here, du gonna be negative e to the negative x power, which is not here on the numerator, right? So du is not there to do the substitution. So the very sneaky thing to do at this point is to multiply by 1. What kind of 1 am I going to multiply by? So here's my sneak attack on this one. Gonna multiply by 1. But this one is going to be, and you'll see why I do this, e to the x divided by e to the x. The reason for that is because I really wanted some e to the x dx so that I can do that u substitution and have the du, right? So when we do that, and this is the sneaky part right there, that's sneaky u, okay? When I do that, I have this become the integration of e to the x on top, okay? And on the denominator, e to the x times 1 is e to the x minus e to the x multiplied by e to the negative x. We know that when we multiply, we keep the base the same, which is e. You add the exponent, and negative x plus x is 0. And we know e to the 0 power is 1. Okay, so look how sneaky that becomes, right? This is pretty awesome. That sneak attack right here will get you this nice looking expression right here. Now you can let u be that. Okay, so from there we would say, hey, I'm gonna let u be e to the x minus 1. Then du is going to be e to the x dx, which is that right there. How nice. That's right there. That's the u. Okay, so this integral then becomes integral of 1 over u du, and that's the one that we know. That is ln of absolute value of u. So our problem then becomes the integral of e to the x over e to the x minus 1 dx, which is going to be ln of absolute value of u, which in this case is e to the x minus 1, and then plus c. That is the answer to this problem. Okay, so why is this a sneaky u problem? It's looks like a u substitution, So you have to do something to it because the du isn't there. And the thing to do is multiplying by 1 right here. Okay, so multiplying by 1, e to the x divided by e to the x. It becomes something really nice right here where you can go ahead and do that u substitution, and that's the du. And it becomes just a really nice looking integral. All right. Okay, so example 2 of the sneaky u type problem. I'm gonna give you this one. 12 divided by 2x to the negative 1 power plus 3, and take the integral with respect to x. All right, so looking at this right here, we saw from earlier when we had that e to the negative x, we do that little sneak attack of multiplying by 1. I think the same strategy will work here if you want to think about it that way, or if you want to think about this x to the negative 1 power as 1 over x, and we can write it as 12 divided by 2 over x plus 3. Now you have a complex fraction, so we can simplify a complex fraction by multiplying by 1, right? So the same strategy as we did before, multiplying by 1. In this case, my 1 is going to be the least common denominator of all of these individual terms, and the only denominator I see there is x, so that would be x divided by x. That's my 1. So when I do that, this becomes the integral of, and I forgot to write the x right there because you gotta tell people what your variable is when you are taking the integral. This becomes what? 12 times x is 12x, and then x multiplied by 2 over x is just 2, and then 3 times x is 3x, and this becomes that. So look at that. Now what are we going to do at this point? This becomes a what type of problem? Kind of like in part 1, you see how we have a polynomial divided by a polynomial. So we're going to go ahead and do a division problem, right? So this is why I call these things sneaky u, because it looks like a u substitution. You should go ahead and do the substitution, but then the u is not there. So you know what are we going to do? Whatever strategy needed to simplify. And in this case, I have a complex fraction, so I'm multiplying by 1, which give me something pretty nice here. It's a polynomial divided by a polynomial, so I'm going to go ahead and do that long division, just like part 1 of this video series, right? So divided by 3x plus 2. Okay, so 3x times what will give me 12x? That would be 4. Okay, 4 times 3x is 12x plus 8. And then what we are supposed to be doing is to subtract. So minus, this becomes a minus. Okay, and that is gone. And the remainder is negative 8. So this becomes, for the quotient, the result of this division is 4 minus 8 over 3x plus 2. That is the thing that is going to replace this part right here. Okay, so our integral, our problem then becomes the integral of 4 minus 8 over 2 plus 3x dx. Okay, so this then, the integral of 4, we know, is 4x. Okay, and the integral of this, well, you know, we're going to do a u substitution, right? So I'm going to go ahead and make some room right here. I'm going to erase that division problem right here. Let's do a u substitution. Let u be 2 plus 3x. Okay, so then my du is going to be 3 dx. That's the derivative of 3x is 3. The derivative of 2 is 0. So then what we have here, we don't have, look at this right here, we don't have 3x, but we have 8x, right? So what are we going to do? We would say 1/3 du is the same as dx. Multiply both sides by 8. We have 1/3 du is 8 dx, which is this part right here. So now that integral, the second integral right here, becomes the integral of 1/3 du. I'm going to put the 1/3 in the front, and that would be 1 over u du. And again, the integral of 1 over u is ln of u, so I have 1/3 ln of absolute value of u plus c. That's the integral for the second part. That's the u substitution for the second part. Okay, so this becomes negative 1/3 ln of absolute value of 2 plus 3x plus c. That is a very, very, very sneaky u. Sneaky u. That's what we call this type of problem, where we gotta do something so that we can do that u substitution. All right.